It's really a pleasure to be in Hacking Paris. It's my first time here, but it's a sad thing to be the last tag. So I'm between you and the wine. I'm going to start with talking about NFC payments, the other relay and replay attacks. But also, I'm going to talk a little bit more about NFC in the core. Who am I? I am a security researcher. Probably you know me about the Samsung Pay flaws that I found like 2 years ago. Also, last year I present about exploiting max try information with Bluetooth audio. And also I'm proudly co-founder of Women in Tech Fund, which basically is a non-profit organization to bring women to these kind of conferences. The content of this talk is about a little bit intro about NFC. I'm going to talk about flow processes, fraud vectors, previous work from Michael Rowland and Peter Fillmore. Also about NFC simulation, of course, relay and replay attacks. Extracting chips data with NFC, something kind of weird, but we're going to talk about that. And smart relays. And finally, we're going to talk about how these relay or replay attacks could affect new technology to come. Basically, NFC technology is a connection between two devices in less than 10 centimeters. And this was adopted in the NFC payment system, of course, because they thought it was secure. If we talk about the RFID spectrum, NFC is between the high frequency, 13.56 megahertz. It is a passive technology, which means that it requires another device to power up that device when you put it closer to the POS, point of sale system, or a terminal. Also, it's widely implemented, and it uses the ISO 14443A. And right now, we are talking specifically to the bank wallet technology. Many people are aware about these kind of transmissions, but they're not really sure how it works. Basically, when you approach let's say, a device or a NFC device to the terminal or the point of sale system, that's when the terminal make a handshake to the device and it start the communication to make the transaction. This something like just to have in mind is like a command. When you're in the shell and the terminal, you send a command and you get a response for the system. It's the same thing when you are making a transaction. The terminal sends a command, the smart card of the, let's say, the mobile device answering the question, and the terminal sends another command, and it keeps going until the transaction is finished. In 4 commands, the transaction has to be finished, so it's less than 500 milliseconds. A little bit about how this works. Basically, when you approach the mobile device to the terminal, it detects the device or the smart card, it lists the applications, selects the applications. It is many different tasks during this process, some kind of restrictions, manage risk, terminal actions, and after that, the transaction has to finish. Completing the transaction with an approved transaction or declined transaction, it doesn't matter, but it has to be finished. To talk about NFC, we need to talk about tokenization process. Basically, the tokenization process is a technique where you have a physical card or a physical, let's say, Visa card, and you are going to add this card to a mobile payment system like Apple Pay, Samsung Pay, or Google Pay. When you add this physical card to this mobile device, the process is we're going to change the physical number to a virtualization credit card number. That means it's a tokenization process. The idea is like when you're going to make a payment, instead of using the physical credit card number, you're using a virtual credit card number just for one time. So if someone intercepts that token, he's not going to use it, or he's not going to be able to use it for a second transaction. The process basically is when you approach Samsung Pay or Google Pay or whatever to the terminal, this token goes to the payment system network, and we have another token service provider which basically validates the token and compare it has already a designation for the physical credit card number, and after that sends back to the bank or whatever, which answer with an approval or denial of the service. So we have 2 technologies, secure element and host card emulation. Basically, secure element we use in Samsung Pay and Apple Pay, and host card emulation we implemented in Google Pay. There are different characteristics. Secure element, more than 20 years in development. Smart card, restrict access, self-encryption. Basically, in self-encryption, we're talking about cryptograms, application transaction counters, and things like that. On the other side, host card emulation, we have limited use keys, basically 4 or 5 keys depending on when you are your card. Google Pay basically downloads these tokens, 4 or 5 tokens, so you can make payments. And of course, is there cloud cryptogram validation. A little bit about the front vector. Sometimes we talk about probably we can make NFC transactions, but they are low limits. Let's talk about the US. We have a limit of $50 for NFC transactions. But if we move this money to another country, let's say South America, that money is going to change a little bit in the value, which probably you can buy different things. So people start using this technique to make these online transactions, thinking about that too. No additional card verification. From bank's perspective, the fraud is considered an accepted risk. And of course, we have NFC in many different devices, and we are going to have in more at home. Attacks in the wild. There is a scenario where a people was in the metro, basically on the subway, and he has a terminal with it, and he was approaching to the people like this is my terminal, and I was like this, and the people was close to him, and he was trying to make transaction implementing NFC. Probably the people was thinking that this was some kind of crazy guy, but he was doing like some kind of interception of transactions to make offline transaction at that time. A little bit about the previous work. Let's talk a little bit about Michael Rowland. He presented a replay attack, the MasterCard in 2013. Basically, what he showed was that he was able to, not to guess, but try to make a brute force in the CBC3, implementing the unique number, putting in 0. So he was able to do that in that way. For 4 transactions, 3 of them were successful, which is pretty cool. About the replay attack from Visa, Peter Firmore presented Black Hat in 2016. And basically what he did was to turn on the master bit and the AI pay. Basically what it does is when you're sending APDUs to a terminal, the terminal asks what kind of technology you're using to make a transaction. And the cell phone say, you know, I have the last technology, so we can do the cryptogram things and things like that. With this changing that, I'm forcing the terminal to make a transaction like max information. So I'm forcing it to load the levels of security in the transaction, which is pretty cool, so you can make replay attacks. Last year in DEF CON 25th, some guys from Asia presented them in the NFC, which basically, they were 2 boards, client server, implementing SDR, 2.4 gigahertz of SDR. But of course, it was a private prototype and a special design. The main problem with this device is because we don't have an open source, so we don't have to, we couldn't test it. So basically, the idea is that you put a client close to the card and the server close to a terminal, and it starts sending the commands between 2 of them. It could be 10 meters, 100 meters, 200 meters, which was the limit of this attack. So let's talk a little bit about NFC emulation. NFC emulation is part of the NFC world. In NFC, we have reader and writer, we have peer-to-peer communication, and we have NFC emulation. NFC emulation is the part where you have a device that basically emulates or behaves like a smart card. So when you approach to a terminal, the terminal thinks that it's a smart card, but basically it's an OR device. In this case, it's in USB PM532. Of course, to run it at Stargate or in emulation mode, you need to implement, we call it native commands, which basically when you connect the USB to your computer and you run a script, when you are using the reader, basically the first command is like, I'm not going to use it as reader, I'm going to use it as a simulation mode, so I can use it to behave as a smart card. There are many different commands to do that, but Adam Lurie designs this library, which basically it has all the commands that you needed to make this simulation very easily. Even it has an example of emulation implementing the PM532 using the ACR122U, which is very easily to implement it in different applications. Let's talk a little bit about the replay attacks. Let's go to the interesting part. Basically, replay attack is when you're going to make a transaction, but something happened between the moment that you validate the transaction and to the terminal. Let's say, for example, that you're going to use Samsung Pay, and it's give you 30 seconds to make a transaction. And you couldn't make it but that token is still alive. I can intercept it, I use it with another hardware. It could be Arduino, it could be different kind of NFC boards. This is a prototype for Raspberry Pi Zero. But specifically, I implement this another the same devices with the price, which is very, very cheap, that you can find online. But this is the project that I made. Basically, it's a Raspberry Pi Zero, the ACR122, a modified version, and a LiPo 3.7 volts, and a zero LiPo booster, which basically what it does is increments the 3.7 volts to 5 volts, so you can use it with the Raspberry. Of course, it's portable. You have an NFC reader and emulator simultaneously in the same device. It's Wi-Fi connectivity, and it's customizable. Of course, it's cheap if we compare it to our devices. So let's try a demo. So basically, I have a Google Pay in this phone. I'm going to run the script. And I have this device ready to intercept the token. When I approach it, basically what I do is intercepting the NFC signal, and I read it. And after that, I'm ready to emulate the transaction in a terminal. So I change the reader mode to the emulation mode. So I'm going to make a transaction, basically. In this case, it's authorizing the transaction because that kind of cryptogram is used in a, let's call it, cloud cryptogram validation, which is already validated. The relay attack is a little bit more complex. We need two devices, one close to the mobile device or the smart card, and another device has to be close to a terminal. The main point here is like we need to make a real-time attack at the same time that someone is going to make a purchase or that someone is not worried about his card and just drop it in this device and get the transaction in the terminal. If we talk about the 10 centimeters between the two devices, how we can expand them. To expand them, we need devices that works very quickly in implementing a lot of communication. In this case, to do that, we use SDR. Some of the inconvenients of this attack are the delays and the waiting time between the transactions. But MFA specifies that 500 milliseconds per transaction, but that doesn't mean that the terminal is going to finish the transaction after that time. If the transaction continues, the terminal, all of them basically, continue the transaction until it finishes it. It could be 4 seconds. The last one I tried, the long time was 4.5 seconds, so it's a lot of time. This is the project. We have two devices called Sentinelas, which basically is the same hardware for the replay attack, but I add the CC1101 transceiver, which basically is a cheap SDR that you can find on eBay. I'm not buying it or using it because it's very powerful. I'm buying it because it's so cheap, it's easily to make a POC with it. You have different frequencies, low frequencies, so the signal can go through the walls, high frequencies for distance. We have different modulations, and you can implement it directly for the Raspberry Pis. To connect it to the Raspberry Pi, you can do it directly to the SPI connector or the SPI and the GPO. So it's very easy to do it, and you have only two dependencies for that. So there are many cables. So I designed a PC board that basically what it does, you connect the CC11 to the top, and you put it on the Raspberry GPO without any issues. Another let's say, limitation of the library is like the payload to send the package between the two devices are the 60 bytes limit. So basically, we have a command of 200 of the APDU of 200. We need to make chunks of 60 bytes or less. So let's see, somehow you need to know, or the device has to know, how to make the chunks. Of course, if you think about it, this kind of chunks is going to add more delays in the communication. But depending on the implementation of the code, it could handle it differently. So we have two NFC readers and emulators. We have Wi-Fi connectivity. It's customizable, it's cheap, and of course, it has SDR support. The idea of SDR support is very important because we need a channel to make this connection very quickly. So we need a dedicated connection. So let's play a relay demo. Basically, this device is going to behave as POS. So I'm going to run the two codes in the two devices in the Raspberry Pis. You notice I already got a card there. It was so quickly because the device, they were very wet. But you will see where is another device located to see the distance of this demo, basically. So I have the two devices, one on the north side of the hall. And the connection was very quickly. And the transmission also was very quickly. So basically, right here, under this device, has the smart card where I got the data. Another concept that I want to talk about is how we can extract data from chip and PIN cards with NFC. It sounds kind of weird because there are two different protocols, but probably you know or probably you don't that they share the same APDU layer. So let's say if I send a APDU command to the contact card and I send the same command to the NFC card, they are going to respond. Somehow they are going to respond with error or whatever, but they are going to respond. That means they are sharing this APDU. And I was able to extract data exploiting basically this APDU layer. Instead of using an ACR122 on one side of the Sentinelas, I changed it with the US Morse card reader. So let's play a demo. I like demos. So basically, I have the chip and pin card connect to my Raspberry Pi, connect to the SDR. And I have another Raspberry Pi, which basically is going to behave as POS. And I have this device, which basically is the POS. And I'm going to extract the data from the chip and pin card. Basically, I got the card sending NFC commands, sending back to the SDR to another USB device, and reading the chip in that way, implementing the APDUs from NFC. The relay and replay attack is a different way to do it. If you think about it, we can send too much data between the relay attack. But what about you can make smart relays? If we take a look about these APDUs, which has many different commands, we can go focus to the cryptogram and to the application transaction counter, which basically are after the red tag in the green side, we have the cryptogram. And the blue one is the application transaction counter. Basically, if I intercept this transaction from the secure element and I try to make a replay, it's not going to work. Why? Because the cryptogram, when I send the save cryptogram to the terminal, when the terminal asks me for the challenge, if I respond with the save one, the POS is going to say that transaction has to be declined because it doesn't match what the challenge was. But if we think about it, the only thing that is changing in a transaction for secure element are the application transaction counter and the cryptogram, which in total they are 20 bytes. What about instead of sending data back and forward in the relay attack, what about just we send the 20 bytes? What I mean with that, I save a previous transaction, I keep it in memory, and when the terminal asks me for the challenge, I ask another device for the challenge, and right now he asks me he responds with the 20 bytes back, and I apply to the save previous transaction. With that, we can save a lot of time in the relay. So basically, this is a previous save transaction, let's say, and now we are waiting for our application transaction counter on the cryptogram. So basically, when the POS asks for the PPC, the first computer answers back. When I ask for what kind of card they are using, the same computer answers back, and we ask him for the challenge. And that time, that computer answered another computer with a challenge, and that computer asks the smart device, and he answers back the challenge that just the 20 bytes, and the transaction can go through. Basically, with this type of attack, we are reducing the time like more than half. So, it's pretty cool. So basically, I have already saved my relay or my transaction in one of the terminals. Right now, what I'm going to do is I'm going to make a transaction with a smartwatch. It's a Fitbit smartwatch, which basically I already saved the previous transaction. Right now, what I'm going to get is I'm going to get just the 20 bytes for the cryptogram on the application transaction counter. And it's very fast, and of course, it's approved because it's how they validated these transactions. New technology. It's cool to talk about new technology. We have new cars that are going to implement NFC to open the doors or to turn them on. And of course, they implement NFC because they use in the NC3320, which basically is part of the schematic of these cards. Many of them, they are implementing this technology. But the question here is, if this could affect new technology, this type of relays, which is going to be very interesting to test them. Let's talk a little bit about web USB, NFC on web browsers. Many people are trying to connect the PN532 to the USB and try to read cards, emulate it. And it's pretty difficult because by default, the web browser doesn't have support for NFC. Of course, they start adding during the last years support, but we don't have a specific library that works for NFC. And I saw many issues. Well, basically in this part, I'm going to talk about Chrome, but I saw many issues that people trying to do that in that way. It didn't work because it's very difficult to do it, because you need to know about native commands, how to answer the questions for the device, but also answer back simultaneously without delaying. So in Chrome, it has this kind of tool that you can enable experimental web platform features to work with USB. So these are some of the issues that people are having connecting directly to the USB cable using a PM or ACR122 NFC reader, and it's very challenging. So I decided, let's think about differently. What about if we connect to another device, this device connect to USB, and now we have support for that NFC reader? And I started looking at, and I noticed that this library, WebUSB, has support for Arduinos. So if we have support for Arduinos, we can connect NFC to Arduino and have directly access from the web browser. So basically, it's a JavaScript, and you have different kind of portions of it and the index of the connection. And it's not very complicated. Basically, you filter what kind of devices you're going to detect with the USB when they are connected to the computer. And after that, in the Arduino side, you just handle the communication between the protocol, which is the serial protocol, and you can start doing things. So let's say, let's play some demos here. So basically, let's say I have this device. It's a key to know with two PM532s. Basically, I'm going to use the red one right now. The idea here is like I'm going to go to the web browser, and after that, I want to run a command to let the web browser, you know what? Let's read a card like I'm making a transaction. Basically, it reads very quickly. But now I'm going to tell the web browser, you know what? I'm going to emulate a card. Basically, I'm going to behave the Arduino that it's a smart card. So I got a transaction like I was using a smart card doing that. Some of the countermeasures that we can use probably in the future is distance bounding protocols. It's very difficult to implement the technology that we have right now because we know what is the terminal, we know what is the card, and what is the attacker. If we think about it, probably the attacker is going to have more delay to make the transactions. But it's very difficult to do it because the attackers could implement the smart attacks or smart relay attacks. And it's very, very difficult to notice the difference between cards, original cards or fraudulent cards or fraudulent transactions. So some conclusions for this attack. Attacker doesn't need a specialized sophisticated hardware to make fraudulent transactions. Even a mobile can be used to a simpler sniffer. but it could be used to make replay attacks. And also, if the companies keep designing their products with proper protections, without proper protections, NFC are likely to be affected years to come. Some credits that I need to thank to these guys for their research and also for their support. Please, if you have any questions, it would be great.